Great. So mixed revision chapter 5, question 1a. Write a number that is 5 thousandths. So let's write that number down. Tenths, hundredths, thousandths. So this number is 5 thousandths, 2 tenths, and 8 hundredths. So that would make the number 285 thousandths. That is 5 hundredths, 2 tenths, and 8 hundredths more than 1 and 4 thousandths. So when we're adding decimals, we just have to line the decimals up. That will give us 5 plus 4 is 9 thousandths. 8 plus 0 is 8 hundredths. 2 plus nothing is 2 tenths. And 1 plus no whole number is 1. So that will be our answer there. 1 and 289 thousandths. Next we have write a number that is 3 thousandths and 3 tenths. So that would be 0 in the ones place, 3 in the tenths place, 0 in the hundredths place, and 3 in the thousandths place, less than 3.411 thousandths. So I just line up the decimals, then subtract like normal. 1 minus 3, can't do it. So we're going to be borrowing from over here. So 11 minus 3 now is going to be 8. 9 minus nothing is 9 hundredths. 3 tenths minus 3 tenths is 0 tenths. 30 minus 0 is 3. So 3 and 98 thousandths. Okay, so figure out what was done each step, either addition or subtraction. So this looks like it's different every time. But 2 and 2 tenths going to 2 and 25 hundredths. Well, if we want to figure out what the difference between those are, I could do 2 and 25 hundredths minus 2 and 2 tenths to get 5 hundredths. So that's probably going to be the easiest way to do it. 0.05. Okay. And so in this case, we are adding from 2 and 2 tenths, or 2 and 20 hundredths. 2 and 2 tenths is the same as 2 and 20 hundredths. I just need to add 5 hundredths to go from 2 and 2 tenths, or 2 and 20 tenths, to 2 and 25 tenths. Okay, now we're going from 25 to 35, and so we're just going to add 1 in the tenths place, so plus 0.1. Now we're going from 2 and 35 hundredths to 2 and 9 hundredths. So this time we're going to be going down from 35 to 9. So 35 minus 9 is, that's going to be what? 26? How about we just do it? Okay. So I just put the largest number on top. 15 minus 9 is going to be 6. 2 minus nothing is going to be 2. 2 minus 2 is nothing. There you go, 26 hundredths. So we're going from 35 to 35 hundredths to 9 hundredths. And so we're subtracting 26 hundredths. Great. Now we're going from 2 and 9 hundredths to 2 and 1 tenth. So we're just going to need to add 1 hundredth, because 9 hundredths plus 1 hundredth is 1 tenth. See, if I have like 100 things, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have 9 individuals filled in, and then I have 1 individual block, I can add the 1 individual block in 9 blocks into 10 blocks out of 100 blocks, which is equal to 1 tenth. So, yep, so we're just going to be adding 1 hundredth here. 2 and 9 hundredths plus 1 hundredth is 2 and 1 tenth. Now we're going from 2 and 1 tenth to 2 and 172 thousandths. And so we're going to just be adding 72 thousandths. Right? And how can I check that? Well, 2.1. I could do the larger number. 2.172. 2.172 is the larger number, minus 2 and 1 tenth. And then that will tell me the difference. So, great. And so in order to go from 2 1/10 to 2 172 thousandths, we'll be adding 72 thousandths. Now we're going from 2 72 thousandths to 2.2 or 2 2/10. And so we have to go from 172 thousandths to 200 thousandths. And that's because 200 thousandths is equal to 2/10. 200 thousandths is equal to 2/10. So we're trying to go from 172 thousandths to 200 thousandths because 200 thousandths is equal to 2/10. Remember, 200 thousandths is equal to 200 out of 1,000. And 200 out of 1,000 is the same as 20 out of 100, which is the same as 2 out of 10. They're all the same. See, we're just taking 1 0 from the end of the numerator and the denominator. So 200 out of 1,000 is the same as if I get rid of a circle at the top and bottom, which is dividing the whole number by 10. 20 out of 100 is equal to 2 out of 10. Okay, so anywho, we're trying to figure out what can we add to 2 172 thousandths to get 2 200 thousandths. Well, so I could just go 2.2 is the larger number minus 2.172 is the smaller number, right? And so if I subtract those numbers, I will get the difference. So 0 minus 2, can't do it. 10 minus 2 is going to be 8. 9 minus 7 is going to be 2. 1 minus 1 is going to be 0. 2 minus 2 is 0. So 28 thousandths. And so we need to add 28 thousandths. 0.028. And let me make sure to add that. Add. Yeah. There we go. Okay, so now we're going from 2 2/10 to 2 1/100. And so 2.20 minus 2.01. See, I just added a 0 here so I can line up the decimals. And so this time we're going down. There we go. We're going down by 1900th. So I'll do a minus sign there. And then finally, we're going from 2 100th to 2. So we're just going to be subtracting 100th. Okay, next, Jack cut 3 8200th meter pieces. So each one of these pieces are 82 out of 1 meter long. 82 out of 100 of 1 meter. So instead of it being 100% of a meter, it's only 82% of a meter. So it's 18% less. From a 4 meter board, how long was the piece that was left? Okay, so I could kind of draw this. So I have a board that is 4 meters long. And I'm cutting what from it? I'm cutting 3 82 meter pieces. So I should write 4 meters because the whole board is 4 meters. And so I'm going to cut off 1 8200th meter piece. That's a decimal. Another, these should be a little bit tinier. Maybe like that. 1 82 meter piece, 8200th meter piece. A second 8200th meter piece. And a final 8200th meter piece. So I'm taking, I'm cutting a total of 3 8200th meter pieces. So how many pieces, how much am I cutting off total? I could find that out by doing 8200th meters times 3, because I'm cutting off 3, and they're all the same size. So 3 times 2 is 6, 3 times 8 is 16, 24. 3 times 0 plus 2 is going to be 2. So we are cutting off a total of 2.46 meters, or 2 4600th meters, from a total of 4 meter long board. And so to figure out how much is left, we would do 4 meters total minus what we're cutting off, 2.46 meter board. So now we just solve. 9 minus 4 is 5, 3 minus 2 is 1. And so we get 1.54 meters left. And I can write that here, 1.54 meter board left. Next, 4A, estimate the total costs in dollars. 4B, find the total. 4C, find the error of estimation. Okay. So first we need to estimate the total cost in dollars. And to do that, we'll be adding all of these numbers up and then dividing by the total amount of numbers. So that would be 5. So let's go ahead and add them all up. Make sure to include our money sign, $4.35, $2.99, and I'm lining all the decimals up, $11.38, $2.14, $7.64. So 5 plus 9 is going to be 14. 14 plus 8 will be 22. 22 plus 4 will be 26. 26 plus 4 will be 30. 3 plus 3 will be 6. 6 plus 9 will be 15. 15 plus 3 will be 18. 18 plus 1 will be 19. 19 plus 6 will be 25. 2 plus $4 is $6. 6 plus 2 is 8. 8 plus 1 is 9. 9 plus 2 is 11. 11 plus 7 is 18. So we're going to add 1 to the tens place, 8 in the ones place. And then finally, we have this one plus this one will be 2. So we have a 2 in the tens place. And so that's the total cost of our money, $28.50 if we bought everything. But we want to find the approximate. Luckily, what we can do is find the error of estimation. Oh, they don't want us to find the average. That's all right. Well, we say it doesn't matter. I was starting the steps to find average, but they don't want us to find average. But luckily for us, 4B wants us to find the total. So we found the actual total, $28.50. Great. $28.50. Estimate the total cost in dollars. I'll just do estimating by I would round each one of these to the nearest whole dollar. So I'll do that right now. $4.35 rounded to the nearest whole dollar. I'm rounding to the whole dollar, so $4. I look to the right, and 30 cents will be rounding down. 3 is less than 5, so we round down to $4. So milk, I'll round up. 2.9 rounds up to $3. Dog food will round down to $11. That's a lot of money for dog food. The broccoli will round down to $2, and the chicken will round up to $8. Great, now I can estimate. $4 plus $3 is 7. 7 plus 11 is 18. 18 plus 2 is 20. 20 plus 8 is 28. $28 is the estimate. If I am writing your guys' quiz in, I will write estimate to the nearest whole dollar, just so you guys know what to estimate to. All right, and then the total is going to be $28.50, right? We found that out. And then the error of estimation, well, if we estimated and found $28, but the real total is $28.50, what would the error of estimation be?
50 cents.
That's correct, 50 cents.
Yes.
Good, okay, and question number 5 now. Factor the following numbers into their prime factors. Oh boy, that means we're going to have to find numbers that can't be divided into. Well, 2 and 48. 2 goes into 48 how many times? 24 times. Great. What about 2 here? 2 goes into 24.
Yeah, 2 and
12.
12. And then it's going to be 2 and 6. And then it's going to be 2 and 3.
Great. And so another way we can actually, it's fine. Let's move on to 5B. But yeah, this works. This is going to be 4 2s and a 3. 2 times 2 times 2 times 2 times 3. Okay. So 71. Man. Who knows a number that could go into 71?
1.
Any other numbers?
71 goes into 71 times.
71 and 1.
What a lame number. So does that mean 71 is prime?
Yeah.
Yes, and trust me, 93 I thought was a cool number, but that one
It can
is
go in
lame
by
as
3.
well. Lame
Yes,
as
be 3.
3.
And so 3 is
3
going to
times
go into
30.
90.
30
3
times.
will go into 90 30 times, yeah, and then 3 will go into 93 31.
31. And I don't think of anything else that can go into 31, so I think that's it.
Yeah.
Great.
I
Okay,
can't believe 71 is that boring.
resume recording. Okay, question number 6. Find the value of x. So what this graph is showing us, or table, or picture, doesn't matter, is 1 and 4600th plus 1 and 4600th plus 1 and 4600th plus some number is equal to 10. So let's go ahead and write that as an equation. Whoop. 1.46 plus 1.46 plus 1.46 plus x is equal to 10. So we're going to find out what 1.46 plus 1.46 plus 1.46 is. And we could do that by multiplying.
Yes, 1.46 times 5.
Times 3.
3.
Great.
3.
So 3 times 6 will be 18. 3 times 4 is going to be 12 plus 1
12
is
plus
13. 3 times 1 is 3 plus 1 is 4. And so now where does the decimal go? Well, we count
right in front of the 3.
To the left of 3. With 1 and 4600th, there are 2 values to the right of the decimal. And for the number 3, there are no values to the right of the decimal.
Oh.
So our answer should have the same number of digits to the right of the decimal as both numbers that we're multiplying by. So there should be 2 numbers to the right of the decimal for the answer, which would be 4 and 3800th. So 4 and 3800th plus x is equal to 10. And so we don't want to know what 4 and 3800 plus x is. We want to know what just x is. And so to get x all alone on this one side, we could do the opposite of what's being done to x. So instead of adding 4 and 3800ths, we want to get rid of it. The opposite of it. Yeah, subtract. So we'll subtract both sides by 4 and 3800th. Okay, 4 and 3800 minus 4 and 3800th is going to be nothing. So this will cancel out.
Is the 10 a whole number?
And yeah, this 10's a whole number. So we're going to have to add some, or just write some zeros in order to subtract it, because we can only subtract and add decimals if the decimals are lined up. So 0 minus 8 is nothing.
So,
oh. All right, so 10 minus 4.38, great. Okay, 0 minus 8, can't do that. So we're going to borrow from the left, can't do it. Borrow from the left, can't do it. Finally, we can borrow here. Okay, so we'll make a 9 in the ones place, and then this will be a 10 here, and we'll make it a 9, and boom, 10 in the, whoops, is there a decimal here? Great, 10 in the hundredths place. So 10 hundredth minus 8 hundredth is 2 hundredth. 9 tenth minus 3 tenth is 6 tenth. 9 minus 4 is 5, and now we have nothing in the tens place. So I'll drop the decimal straight down, and there we go. It seems that x, which is left over, x is equal to 5 and 6200th. Okay, next we are going to calculate. Okay, so these questions, I'm guessing they look pretty difficult. There's actually a trick, and so here's the trick. So if we have 2 times 10 to the 4th power, let's figure out what 10 to the 4th power is. 10 to the 4th power is equal to 10, 10 times 10 times 10 times 10, which is the same as 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000. And so you see, 10 to the 4th power is equal to 1 with 4 zeros after it. How many zeros? 4, because we're 10 to the 4th power. We're going to have 4 zeros after the 1. And that trick always applies. So, for example, 10 to the 4th power, we already just found that out. 10 to the 4th power is 10,000. 10 to the 6th power, well, that time it's just going to be 1 with 6 zeros after it, which is a million. 1, 1 0, 2 0, 3 0, 1 4 0, 5 0, 6 0. 10 to the 6th power is a million. And then here we have 10 to the 3rd power, which is 1,000. Okay, so how does this trick help us? Well, now that we know that 10 to the 4th power is 10,000, now when I do 2 times 10,000, that's going to give me, well, I'm just going to do my 2 times the 1 in the number. And so, and then just what they write in the book, they say, what does it say, add? They don't say add the zeros. Like ping or something, some weird number. You just write the 0 after. So in this case, 2 times 1 is going to be 2. And then there's 4 zeros after. So I'm going to write 4 zeros after for my answer. 1, 2, 3, 4. 20,000. So let me go ahead and try that with the rest. So 10 to the 6th place, 10 to the 6th power is 1 million. And so 9 times 1 million is going to be, someone shout out?
9 million.
Good, 9 million. And so this will be the last one to shout out, okay? 17 times 1,000 is?
17,000.
Good, 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 good. So I'm hoping that you guys start getting that pattern. And the most important pattern to know is 10 to the power of anything, let's say anything, is equal to, it's going to be a 1 with that power of zeros after. 1, 2, 3. Okay, a couple more questions on this page. Write a division equation where the quotient is 210, the divisor is 52, and the dividend is unknown. Well, divisor and dividend, both those numbers both sound like they're going to have division done with them, right? Divisor and dividend. Divisor and dividend is for sure going to be on this side. The answer of your division question is called your quotient. So we know that for sure. Or I know that for sure, at least.
52 is going to be right in front of 210.
Yeah, so what the number that you're dividing by is called the dividend. And the number
So that means the divisor is going to be in front of the quotient.
Yes. Actually, let me say that one more time. The number that is being divided is the dividend. The number you're dividing by is the divisor. There we go. Divisor. And then finally, the answer is your quotient. Quotient. Great. And so we know that the divisor is 52, and so it should go here. Well, I don't want to figure out what this whole thing is, because that would be kind of a pain in the neck. If I have some number divided into 52 groups, there will be 210 in all. Well, I could do the opposite. Some number divided into 52 groups with 210 in each group is the same as if I have 210 in each group and I have 52 groups, how many do I have total? And so, see, I'm just going to do the multiplication. Right, I'm doing the opposite. The opposite of multiplying is divide. So instead of doing some number divided by 52 is 210, I'm going to do 210 times 52 is some number. Great, so 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. Now we're going to the tens place. 5, but in all actuality, we're not doing 5 times 0. We're doing 50 times 0. 50 times 0 is going to be 0. Now we're doing 50 times 10, basically. And 50 times 10, or 5 times 1 is 5. And there's 2 numbers after it, and that's because 50 times 10 is going to have 2 zeros after it. Okay, let's just continue for normal. 5 times 2 is 10. Great. Okay, and now we can add these numbers up. This number that you guys got? 10,920? Yes. Good, great. Okay, next we have 9 and 10. Question number 9. Mark the numbers given in the problem in the bar number. Okay, mark what is asked with question mark. Then solve the problem. Mary and Louisa bought a gift together for $46. Okay, so one of these is going to be Mary, one of these is going to be Louisa, and they bought the gift together for $46. So, I'm guessing this is what one of them paid, this is what another of them paid, and then together they paid 46. And so adding both of the bar graphs together will be 46. Great. Mary spent $6 more on it than Louisa. How many dollars did each girl spend? Okay, Well, Mary spent more than Louisa. So her graph makes sense that it's the longer graph. So I'm going to label Mary next to it. And then the other one was Louisa. And so we were told that Mary spent $6 more than Louisa. So that would be this little part here. This is $6. How do we know it's $6? Well, we know they spent the same amount. You see, they both have a green. They spent the same amount, except Mary spent $6 more. So Mary should have the same amount as Louisa plus $6. And so I know that both these green bars are exactly the same. Why? Because they both spent the same amount, except for Louisa spent $6 more. So that means that, I'm sorry, Mary spent $6 more. And so that means that both Mary and Louisa should have the same amount of green, this green here, because they initially spent the same amount. Okay. So I'm going to label Louisa and Mary's same amount with, they asked me a question mark. Usually I would use X, but they asked me question mark, and so I will listen and write a question mark here. Okay, and so how do I figure out how much that question mark is? Well, I know that if we add Louisa's question mark and add Mary's question mark and add $6, it should all come together and make a total of $46 because that's how much they paid to buy the item. So question mark plus question mark is plus $6 is equal to $46. Okay. If I have a question mark plus a question mark, I can simplify that, or another way to write that is 2 times question mark. It's kind of like if I have 5 plus 5 is 10. 5 plus 5 is the same as 2 times 5. So 2 times question mark plus $6 is equal to $46. I don't want to know what 2 times question mark plus $6 is equal to. I want to know what just question mark is equal to, or just 2 times question mark. So I want to get rid of the $6, and to do that, I will do the opposite of add $6, subtract $6 from both sides. And so I will have 2 times question mark is equal to $40. Well, the problem is I want to know what just 1 question mark is equal to. What is just 1 question mark equal to? Well, 2 question marks is equal to $40. I don't want to know what 2 question marks is equal to. So to get rid of this 2 times the question mark, I have to do the opposite of what times 2 is. And so I'm going to divide both sides by 2. So 2 divided by 2 will be nothing on this side. And $40 divided by 2 is $20, which leaves me with question mark is equal to $20. How much did each girl pay? Each girl paid at least $20. So the last thing is, it says how many did each girl spend? This would be tricky. You need to make sure you write this part. Louisa spent, so she spent a total of 1 question mark. So how much did she spend? $20. Good. And then, right here, and Mary spent, she didn't just spend a question mark, she spent a question mark plus $6, so she spent $26. Great. And so that would be question number 9. And so we have one last question on this page. With the money John earned from his summer job, he paid his phone service for 2 months, $48 per month, spent $120 for a bike, and still had half of his money left. How much did he earn? Okay, so we're asking how much he earned total. So with the money John earned from his summer job, he did all this. Okay, so I'm going to create a bar that tells me how much he earned in summer. August is equal to summer money. That's fine. Summer money. I don't know how much it is. I know it's something. Okay, so what did he pay? Well, he paid for his phone service for 2 months, $48 per month. So he had to pay $48 2 times because he has to pay for it monthly. So I'll say this will be for 1 month, $48. And this will be for another month. Oh, that's really long. Let me make it a bit shorter. Like there. And there. That'll work. So $48 here. And $48 here. Okay. And he also spent $120 for a bike. $120. It's a really tiny $120. And still had half of his money left. How much did he earn total? Okay. And so if I'm going to cut this graph in half, and for this, I'll just write Y. This is how much money he has left. Y is how much money he has left. Okay. Now I can start doing the math. How am I going to do the math? Well, everything in the bar adds together to give the total. And the total is his summer money. So I'm going to write Y plus 40, let me zoom out a little bit or scroll down. Y plus $48 plus $48 plus $120 is equal to total summer money. Another way that I could do this like way easier, I could just do it in my head, so I'll tell you the answer real quick. Is we know that he spent $48 plus $48 plus $120, then he had half of his money left. That means that what he has left is equal to how much he spent. So hypothetically, we could just add how much he spent, and that will tell us how much he has left. Does that make sense? And that would be $96, $90, $216, right? But it's all right. We could also calculate it. Okay. So how about we start by adding up how much he spent? Because $48 plus $48 plus $120, we could do that. So 120 plus 48 plus 48. 8 plus 8 is 16. 4 plus 4 plus 2 plus 1 is going to be 11. And 1 plus 1 is 2. Hey, $216. Great, okay. So I know that Y plus $216 is equal to his total summer money. Great. Okay, where to go from here?
We add 216 and 216.
The problem with that is we have a variable on both sides. What's that mean? Well, we don't know what Y is equal to, and we also don't know what total summer money is equal to. And so the problem is if we do minus $216, minus $216, that would say how much money we have left is equal to our total money minus $216. But we actually kind of already know that. Total money minus $216. So to be honest, all we have to really do is look at the question and analyze it. I don't think this one is as much with the math because it says that after he spent his money on three things, $48 plus $48 plus $120, that gives us $216, and he still has half of his money left. Yeah, there's not really a math question we could do at this point. All you need to know is that if he has half his money left, which is Y, then the money that he has left must be equal to the money that he spent. So just Y equals $216. That's fine. But the last thing we need to do is we need to calculate how much total money he spent. So if he spent $216, or how much total money he got. If he spent $216 and he has $216 left, then all we need to do is multiply or do 216 plus 216. That's fine. And that will tell us how much money he started off with. $432. Okay. Boom. 11. Divide, check your answer by multiplying. Okay, so we'll start with 38 divided, or 3,952 divided by 38. So can 38 go into, how about I use a different color? Can 38 go into 3? No, it goes in 0 times. So 38 times 3 is 0. 38 times 0 is 0. 3 minus 0 is 3. Drop the 9. Okay, can 38 go into 39? Yes, it goes in 1 time. 38 times 1 is 38. 39 minus 38 is 1. Drop the 5. Can 38 go into 15? No. Goes in 0 times. So 38 times 0 is 0. 15 minus 0 is 15. Drop the 2. Oh, great. Well, I could kind of guess in my head. 38 rounded up is going to be 40. And so 40 goes into 150 about, I'm going to guess 3 times. So how about we try that out? 38 times 3. 3 times 8 is 1624. 3 times 3 is 9 plus 2 is 11. Can 38... So 114 definitely goes into 152. But can we, if we added 38 to 114, will it still go in? What I'm calculating right here is 38 times 4. Because I did 38 times 3 plus 38 will be 38 times 4. So let's see. 8 plus 4 is going to be 12. 5. 1. Oh, wow! 38 times 4 goes into 152 exactly. So 38 goes into 152 4 times. 4 times 38 is 152. 152 minus 152 is 0. Woo. So remainder, nothing. No remainder. Goes in exactly. Great. So now we have to check. And so if we have 3,952 and we divide that into 38 groups, and there's 104 each in each group, how we could check our total is do 104 times 38. So if we have 38 groups of 38 groups of 104 items, then how many items do we have total? 8, 16, 24, 32. 8 times 0 plus 3 is going to be 3. 8 times 1 is 8. Next number. 3 goes into 412. Or 3 times 4 is 12. 3 times 0 plus 1 is 1. And 3 times 1 is 3. So 3,952, we could check our answer, and that is absolutely correct. I guess I should write this up here, 104. Great, okay. More division. Okay, so this time we have a decimal. That's no problem at all. So we're how many times can the number 17 go into the number 268 and 6/10? So, okay. 17 goes into 2, 0 times. 2 minus 0 is 2, drop the 6. Okay, 17 goes into 26 1 time. 16 minus 17 is going to be 9. Boop. Okay, drop the 8. Oh, well, let's just say I round 17 up to 20. I would say it's going to go in about 4 times. Maybe 5. Probably 5. How about I try 5 first? 5 times 7 is 35. 5 times 1 is 8. Okay. Great. Looks like 17 will not be going in to, and again, this is what I'm doing basically. I'm trying to find the largest number that could go in, right? And so I think maybe it's 5. Maybe 17 goes into 98 5 times. And I look at 85 and I say, oh, if I added 17 to 85, it would go over 98. So that looks like my right number. Okay, so 17 goes into 98 5 times. 17 times 5 is 85. 8 minus 5 will be 3. 9 minus 8 will be 1. Drop the 6. Okay. So you guys see what I'm doing? Since I have these big numbers, I'm trying to round what I'm dividing by to a number that's a bit easier. So I was rounding 38 to 40 to kind of guess, and now I'm rounding 17 to 20 to kind of guess. So how many times does 20 go into 136? Well, that's going to be about 6 times, maybe more. 17 times 6 is probably going to be 17 times 7, isn't it? Oh boy. 6 times 7 is going to be 42. 6 times 1 is 6 plus 4 is 10. Yep, looks like it could go in again. 17 times 8. Let's try 7. Okay, 49. 7 times 1 is 7 plus 4 is 11. Can we go in again? Oh, I think we could go in exactly one more time, I'm guessing. So 17 times 8. 8, 16, 24, 32, 48, 56. 8 times 1 is 8, plus 5 is 13. No falling asleep since. Okay, perfect. Oh, yeah, and I guess I have to write that down. 17 goes into 136 8 times. 8 times 17 is 136. 136 minus 136 is 0. And the last most important step that I don't want to forget is I was lining, I need to raise my decimal straight up. Great. And so 17 goes into 268.6, 15.8 times. Let me make this a better looking 0. 15.8 times. And so to double check this, we will do 15.8 times 17. We don't need to line up the decimals because we are multiplying by decimals. Yeah, if we're multiplying, we don't have to do it. Okay, so 7 times 8, 56 again. 7 times 5 is going to be 35 plus 5 is 40. 7 times 1 is 7 plus 4 is 11. Boop. Now 1 times 8 is 8, 1 times 5 is 5, 1 times 1 is 1. Add all the numbers up. 6 plus nothing is 6, 0 plus 8 is 8, 1 plus 5 is 6, 1 plus 1 is 2. And finally, we count how many numbers are after the decimal. And so we have 1 number after the decimal in 15.8 and 0 numbers after the decimal in 17. And so in our answer, there should be 1 number after the decimal, giving us the answer 268.6, which is exactly the same as what we were dividing by, which is great, or else that'd be pretty embarrassing for me. Okay, question number 12. Solve the problems. Choose if you use mental math or a calculator. It doesn't really matter. I know for this one, I'm going to have to go from left to right. 140 minus 70. 14 minus 7 is 7. So 140 minus 70 is 70. 70 minus 30 will be 40. Great. Next. 529 minus 71 times 6. I'm not sure if I want to do that one mentally. So I'll do 71 times 6 first because PEMDAS. So I need to do 71 times 6 first. 6 times 1 is 6. 6 times 7 is 42. Now we're doing 529 minus this number that we got, 426. 9 minus 6 is 3. 2 minus 2 is 0. 5 minus 4 is 103. Next, 7 times 80 plus 1,000. We have to do the multiplying first. 7 times 80 is the same as 7 times 8, and then whatever answer you get, add a 0 to it. So 7 times 8. Didn't I just do this one? I'm going crazy. 8, 16, 24, 32, 48, 48, 56. Yes. 56, and then we're going to add a 0 on it because we're just doing 7 times 8, and then we put the 0 right on the answer. 560. Okay, so 7 times 8 is going to be 560 plus 1,000 is 1,560. Okay, your change from $100 when buying 3 packages of paper for $16.65 each. So I'm starting with $100 minus I'm buying 3 packages of paper for $16.65 each. What's my answer? So 1665 times 3. I'll do it up here because I'm running out of space. $15, $18.19, $18.19, 3, 4. Great. Okay, and so 2 numbers after the decimal, 2 numbers after the decimal for the answer. So 3 times 1665 is 49.95. And so now we just subtract 100 from it. So I better make sure to line up my decimals. 100 and 0 cents minus 49.95 we have to carry the 1 all the way over there. There we go. 10 minus 5 is 5. 9 minus 9 is 0. 9 minus 9 is 0. 9 minus 4 is 5. Great. Did you guys get $50.05? Yeah, like the thumbs up. Oh, $50.05. Okay, next, the total cost of 5 flash drives at $24.95 each. Okay, all I need to do is multiply. So $24.95 times 5 flash drives. 5 times 5 is 25. 5 times 9 is going to be 45. Plus 2 is 47. 5 times 4 is 20. Plus 4 is 24. 5 times 2 is 10 plus 12. Okay, plus 2 is 12. Great. Now we figure out where is our decimal going to go. We have 2 numbers after the decimal here and 0 numbers after the decimal here. So our answer should have 2 numbers after the decimal, giving us an answer of $124.75. Can I get some more thumbs up for who got that right? Okay, and then we have 12F is how many inches are in 5 feet? Oh, and they even tell you 1 foot is 12 inches. Well, I'll do 5 feet times 12 inches. I know that one in my head is 60, but I'll do it anyways. 5 times 2 is 10. Whoop. 5 times 1 is 5 plus 1 is 6. 60. Yay, 60 inches in 5 feet. Last question after all these years. Match the 2 problems A and B to the correct expression below, then solve each problem. What does your answer signify? Okay. John has $170 to buy groceries for the week. First, John sets aside $23 to buy treats. Then he divides the remaining money evenly for each day of the week. Okay, so we're going to start with $170. Then he's going to set aside $23 to buy treats. So he's going to pull $23 out of this amount. Now he has that saved. And then whatever's left, and so I know that's going to be 147, right? Whatever's left, he's going to divide evenly by the rest of the days in the week. The problem is if I just added divide by 7 here, PEMDAS, if I looked at PEMDAS would screw up my whole problem, and that's because I do parentheses first, then exponents. Okay, there's nothing there. Then multiply and divide. Oh, do I want to do 23 divided by 7? Am I going to use that $23 of treats and divide that number by 7? No. No, I'm not. I want to do $170 and then subtract $23 first, then divide by 7. And so I need to add parentheses right here to make it very clear. You subtract $23 first to make sure you have your money for treats, and then you divide by 7. Great. And so that is going to give us this one here. So now we can solve. $170 minus 23 will give us $147, right? And then we divide that number by 7. And 7 goes into 147. That's going to be 21 times, right? Because 7 times 1 will be 7, and 7 times 20 will be 140. So 21, right? 7 times 1 is 7, 7, 14. Yeah. It all makes sense. Great. Okay, so this is how much we'll have per week. And are we supposed to solve the problem? Then divide each. Yeah, okay. I'll just write this. John will have $21 to spend on food each day. Next, John has $170 to buy groceries for the week. John decides to use $23 per day for food and use whatever is left for treats. Okay. Interesting. Oh, great. Well, then this is the function we're going to be using. Why is that? Well, we have $170 total to spend all of our money on food. And then what are we taking away from this? Well, we're subtracting from $170 what we'll buy every day. And every day we're going to be paying $23. And how many days are there? 7 days. So $170 is our total money. And we're taking away from it 7 times for 7 days of the week. And every day, how much are we taking away? Times $23. This would be the function that explains this word problem. We start off with $170, and then over the course of 7 days in the week, every day we spend $23 on food. And so what will we have left? Well, whatever is left will be $170 minus 7 times 23. And I guess we could calculate that. 23 times 7, 7, 14, 21, 7, 14 plus 2 is 16. Great. And so it'll be 100. So 7 times $23 will work out to $161. And $170 minus $161 will give us a total of $9, right? And so for B, I will write John will have $9 left for treats. Yeah, we got a 100% on our quiz, unless Mr. Barry made a mistake. So